This video is a bit of a continuation from my prior video, which leveraged this keyboard, this add-on to a F256 Junior for MIDI, general MIDI rather, and the Dream chip. Today we're going to do something different. We're going to be talking about the SID chip. Of course, all Commodore people know about the SID chip, and many Phoenix people do as well, because Stephanie ships these Juniors with 2 open slots for SID chips. Some of her other machines have had SID chips. Her newest machines have SID, Gideon SID FPGA instances built into them. The SID's the SID is a wonderful chip developed in the early 80s by Commodore. Bob Yanis, I still can't pronounce his name, or don't know how to pronounce his name. He was the engineer that I think really drove getting this thing delivered for Commodore. And it's been used on multiple platforms. There's tons of stuff online about it. There's the whole scene and all that business, which I don't know anything about. But I know a lot about how to get some good sounds out of this thing, and I've created a tool which will help further. So I have an article I wrote in February, or I guess I edited it through February, during what I called Beta 2 of this piece of software called SIDlab, and I'm here today to demonstrate just kind of basics of how the thing works. It's going to be a 15-minute video, 20-minute video, if I can get everything under the wire as I speak. But I'm going to read you the introduction, bring it up on the machine here. I'm capturing it, the video and the audio, and we'll see how far I can get. Anyway, the premise is that it's a playground, right? The SIDlab is a playground for experimentation with your physical MOS 6581. That's the original Commodore 64 SID chip. The MOS 8580, which was in the 128, maybe in the 64C also, I'm not sure. Also works with pin-compatible replacement SIDs like the ARM SID, back SID, or Swin SID. I happen to have 2 back SIDs here. And it works with Gideon SID. So anything that's an actual SID sitting inside of an F256, or if you have the F256K with Gideon SIDs built into them, which they all do, you can use this software. It helps if you have a MIDI keyboard. I'll talk about that in a moment. But in closing, this document talks a lot about how I got to this point. The software is written in 6502 assembly language. I do plan on porting this to the Commodore platform, one way or another, which means I have to back out some of the 65C02 opcodes that I used, which won't be a problem. So I'm looking forward to that. My goal here is to deliver this thing. I'll be releasing the beta 3 for people to download. Interestingly, this document, 8 pages, was downloaded well over 100 times from the Phoenix Marketplace. See the link below. And nobody's asked me for a copy of the software to try out on their machine, which I find amusing. But I'll be posting the software to the Phoenix Marketplace. Anyway, lots of features, more features coming, and I've been refining the feature list across many months. I did take a pause to work on some other projects, but I've got about 3 months of solid development in this thing. And this map, as of February, shows every feature and function, which some have moved and changed. But in essence, this is everything. Page 6, I believe. Yes. 6 is the voice features. So you know that the SID has 3 voices. So if you press, for instance, S, while you're on, voice 1 selected, it'll change it to sawtooth. P changes it to pulse. E to enable the filter for that particular voice, and you can change other things as well. Envelopes, importantly, you use HUJK. Why? Well, it kind of looks like this, and I'll put this graphic on the screen. Somewhat interesting, but at least it's a way to remember it. The second layer, so to speak, is the global scope. And these are things that affect the entire synth chip or the software in general. Things like the volume, the filter cutoff, LFO type activities, filter resonance, etc. And then finally, there's the performance features, which are things like pressing a key on the keyboard to make it play note C if you don't have a MIDI interface. Starting a sequence, which I'll get into. The sequencer is one of the more fun features of this thing. So have a look for this if you're interested. Now I'll get to it. I'm going to load up the binary, which is actually I need bload SIDlab .bin. Yep. and 2000. I'll take 2000 with the, not a number sign, but a dollar sign. Okay. That'll take a moment to load. Hardware setup here, I've got this with a MIDI connection into this adapter that I put together myself. Maybe one other person in the world has one of these on their F256, but all the F256 K2s come with an optional MIDI in-out and Dream chip, which is a good thing. The Dream chip comes in all of them, but the MIDI connections can be ordered for like, $20 or something. Stephanie will solder the 5-pin in ports on for you. Should be good to go. There I am. Okay, I'm going to bring this up with a call 201A. All right, you probably heard that song before. The origins of the software really came out of the Commodore Christmas demo and the work I did for Make a Phoenix demo based on the Commodore Christmas demo music in December. Newsletter 12, I think, Phoenix Rising 12 or 13 has a write-up about that. But I, been evolving this kind of concept and finally come up with the idea to make a full-blown, studio, so to speak, to craft your own sounds. The moment I pressed the space bar, I paused the music playing. I'm left with oscillators configured as that sound required. But I can change any aspect I want, but I'll leave it like that for the moment. Simply, if I press a key like C, I can hear the way that oscillator 1 or voice 1 was configured. And you note on the screen, let me turn the mouse on, by the way. So you'll note here this control register. It's 1 when the key is down, it's 0 when the key is off, and that's the gate. It's bit 0 of the control register for each of the 3 voices. I'm going to give you a quick tour of the interface, and then we'll jump into kind of an audio demo. To start with, you've got, the music keyboard here, which you can click on, or you can say, numbers 4 through 0. So, I don't know, and note if I push down and hold down, the gate's on until I let go of it, then the gate is off. So that's kind of the first thing. Next thing is waveforms. So I've got pulse selected here. If I press, T for triangle, I'll get the triangle waveform, which is more of a bassy, rather low. I can do a whole bunch of things. But let me quickly finish talking about the interface, and then I'll play some different sounds for you and explain some of the thirds, fifths, and sevenths. To start with, I mentioned the keyboard. It includes a full-featured LFO. In fact, I'm going to have 3 of them. 1 will be MIDI synced, 2 will be like this, and you can cascade them. I can turn on the LFO by clicking here, and you'll see now that the LFO is moving at a pretty slow rate, left to right to left to right. This is the triangle waveform. You can also press Control L, right? Not everybody has a mouse on a Junior, so Control L will advance this setting to ramp, sawtooth, sample and hold, low range sample and hold, medium range sample and hold, high range sample and hold, back to off. Pressing the key without a caret in front of it, when it's underlined, like this L, capital L, well, it's not capital L, it's an L, will change the voice destination from frequency bound to voice 1, pulse width modulation, the envelope, sustain stage, and filter cutoff. Okay, so there's other things you can do, like you can, I may as well just do it while I'm here. I'm going to turn the pulse width on. I'm going to, let's see, going to turn on, I guess, yeah, I will turn on the LFO. I'm going to change this frequency, destination to cutoff, filter cutoff. I'm going to, actually I'm not going to, I'm going to go to pulse width to start with. Now I'm going to go to turn the LFO on, Control L, and I'm going to press the key. Hear that? It's more pronounced with a thinner pulse width. So I'll go Control W will change the width of my waveform. Hear that? Now I can change the speed of the LFO by pressing the greater than sign here. You'll note, if you look right here, watch the speed. And that's a free running oscillator. I can also do things like change the instead of being a triangle, I can change it to a ramp, which is only one direction. So now it's going from right to left. I'm going to slow it down so you can see it. Okay. Now this is the pulse width changing. It's not as really prominent or noticeable as it will be as bound to filter. So what I'm going to do now, I'm going to enable the filter for this SID, right? There's two SIDs in here, by pressing Control F. See that? Caret F, Control F, turns it on. It's a low pass filter. Now I have to configure this voice to go through the filter by clicking here. And now when I press a key, you can barely hear it. Well, that's because the filter is set to, where are we? Cutoff. It's set to 0, which is absolutely closed. But what I'll do is I'll change this LFO destination to the cutoff. Notice the voice is bound to 1, voice 1. When I get down to filter, that's for the entire chip. So you'll see that I'll go to filt. Now when I press a key, now I'm going to put it up to triangle again. Back and forth. Increase the speed. Now that's something that most applications don't have, because there was no envelope for the filter. The SID chip certainly has 3 envelopes, 1 per voice, but that's an amplitude envelope. This is for volume. Does not have one for the filter. So I'm using the LFO as kind of a continue rolling filter, a continue rolling oscillator to drive the filter cutoff. Now if I hold down a control key here, notice the cutoff here. Watch what happens. Oh, over here, sorry, the high byte. It's continuously changing from 0 to 255 to 0 to 255. And it's going on a triangle waveform. So it's kind of going up and down, up and down, up and down. Up to 255, down to 0. Up to 255, down to 0. I can change the dynamics of how that sounds by picking a different waveform, like let's say ramp, and I'll do that by clicking in Control L or pressing that, and now you can see it's only going up. 0 is on the right, 255 is on the left. It's rather fast, too fast. So I'm going to slow it down. The other thing I can do is, rather than being free running, so if I press it here, beginning of the wave, if I press in the middle or the bottom, different results. I can phase lock it to my pressing of the key, so it's gated to the oscillator in voice 1. I do it by pressing Control P on the keyboard. Now you'll see it's bound to voice 1. The rate didn't change. It's still running freely, but if I press a key now, watch it reset to the beginning, to the right. So that's the equivalent of having a separate envelope tied to the filter, as most synthesizers have. A pretty handy feature. I can also change it from a ramp, which is what it's at now, to a sawtooth by going 1 click ahead here or pressing Control L. Now it'll start on the other side and head downward. Here, close towards the right side. Listen. Actually, a little blip. Depending on where I let go of it, the rate is such that you'll hear it open up again or reset to 255 right as the amplitude envelope over here closes. which is set to a 9 at the moment. So I will do two things I can do. One thing I can do is I can make this a little bit higher, and then you'll hear the tail end of it kind of echo. So I'm gonna press. By the way, I can select it here too. This pad selects voice 1. This is the you can see that change. I'm gonna change it to, I don't know, B. See that? I can change the speed too. It's starting to turn into a synthesizer, isn't it? Other things I can do, I can tie this to any voices, by the way. I can set an envelope trigger so that every time this wraps around, it triggers the voice, kind of the opposite effect. You can consider that kind of like a gated, a clock-driven gate, like some synthesizers have. You can also change the top and bottom of the LFO from 0 to 55 to a limited range if you like to. You could also pick sample and hold as a wave source. So I'm going to press Control L one last time, and now you see it's jumping all over the place, right? I'm going to turn off phase lock by pressing Control P a few times. Okay, now I'm going to hold down a key. Listen. Too fast. Let me slow this down a little bit. And what's that doing is turn the resonance up actually with the alternate R. Turn it all the way up. It's gonna be louder. There we go. Now, what that's doing is it's using the RAM number generator built into the VIC 2 chip, VIC 3, VIC Junior. What's the name of it? Crying out loud. Tiny VIC, I think is what she calls it. It's using the random number generator built into the kind of the math coprocessor portion of VIC to pick a random position from 0 to 255 and apply it to the filter cutoff. This is used in a couple of real classic synth tunes, but the full range is not always appropriate. So what I do is I give you, let me change I'm going to change to a, I think bandpass filter here. Let me go. That's better. Bypass. I'm going to speed this up a little bit. Now sometimes you want it in a certain range, so I created 3 different modes for the sample and hold. There's a low mode. The normal unselected mode is just the whole range. I can go low only. You'll notice it's in the bottom third, roughly. Almost sounds like a formant filter. Let me change the width of this actually to I like it best down here actually. There. Now I can change it to mid-range. See right here in the middle, right? I can change it to the to the highest frequency only. Barely hear it. Not really appropriate for this type of playing. But those are some of the features of the different waveforms for the low frequency oscillator. I mentioned the cutoff destination for sure. Frequency destination is a bit of a weird one. It's all over the map. I'll need to press L to shift it 1. It's tied to voice 1 now. Hear that? I'm going to turn off the filter. You wouldn't want that on a sample and hold unless you have a computer sound inside of the game Impossible Mission where the computer's doing something in the background. But let me change this to... There you go. You get the idea. So anyway, that's that. Pulse width modulation I did already, and then this has to do with the sustain level of the envelope. So I spent more than enough time on the LFO. Where am I? I'm 20 minutes in already. I'll tell you what. I'm going to close this. Actually, I'm going to show you two other quick things, and then I'm going to close this video down. But the last thing I'm going to show you, you're going to like a lot. I have a funny feeling. I'm going to turn this off, back to the top. And I got to turn, I have to turn, let's see, where am I? Frequency. Probably the, yeah, my frequency is so low, keyboard's so low you can barely hear it. That's what it was. Sorry about that. Okay, I'm going to tell you that there's a second mode of this thing, which is the stack mode. So the channel mode, which I've been demonstrating, is just playing a single channel, single voice. There's a way to play all of these stacked together, which many of the SID tunes actually do, or SID sound effects certainly will. To change the mode, I'll press enter here. Now you'll hear something a little bit out there. Now you'll notice by the numbers that the frequency of all three oscillators is identical, right? 61808. They're identical. So you're hearing the same tone across all three. The only difference is this one has a very thin pulse wave, and one of these is misbehaving and has a very long release. And of course, it's the one we were messing with here because we wanted that kind of repeating echo effect. So I'm going to change that. And the second one, let's see. Second one, this is a 9, and this one over here is an F. Well, it's the third one. There you go. Okay, now I have an option to turn this an octave down. And I have an option to change the upper voice an octave up. Hard to hear, but you can tell by the numbers that it's clearly working. Let me turn this off. Turn this off. Oh, it's because sync's on, that's why. There you go, now you can hear it. Let me turn this back on, and turn oscillator sync off by pressing O. There we go. Now we're getting kind of the buzziness here, and the rest of them similar envelopes. Now I can do things like select a major third for the interval between the first voice and the second voice by pressing Control 3. So you can see major 3 was checked, and now or I can get a perfect fifth by pressing 5, Control 5. I don't suppose there's many Devo fans out there, but anyway, if you can select both of these, you'll get a minor seventh, which is unusual and dissonant, but it's useful when you turn oscillator sync on. Let's see if I can do it. Is it this one? This one's be down. Yeah. In this range is where we heard most. Hear the beating? Almost like a video game effect, huh? And it wears on the ears after a while, but there's applications for having oscillator sync on with an offset that's unusual or otherwise unusual. Let me see if I throw this through the filter, what'll happen. And then I'll get to kind of the punchline here. I want to pick a different filter. I'm going to go... Okay. Now what I'm going to do is I'm going to get to the punchline, which is you get a rough idea of the kind of things you can do with this, which hopefully you find interesting. I didn't mention it, but there's multiple paraphonic modes, which I'm still working on. And what happens is you hit enter again or control M, and you'll get a round robin voice distribution mode, a stereo pan, which is essentially really just the SID on the left playing only on the left, the SID on the right playing only on the right. You can play with kind of two hands on different MIDI keyboards, different channels. There's a voice reset, which will reset the voice when you let go of a key. It'll reset the allocation engine such that it is, I'm still working on it, such that the notes get spread out across the voices, which can be all configured differently with quite an interesting effect. The Oberheim 4 voice had this feature back in the 70s, and there's a Moog grandmother has it today. It's pretty interesting. And finally, there's a split, where you can set a split point and it'll send all the notes to channel 1 south of the split, all the notes to channel 2 north of the split. So those are some things that I'm working on. So let me get to the a punchline, not the punchline, but a punchline to close this video down. I'm 26 minutes in, so that'll be about 30, not 20. Let me turn the filter off. That high-pitched sound, by the way, happens when you've got filters selected. The SID is a quirky beast. Let me do this again. Turn this off. Oscillator sync. 2 and resonance, I believe. Okay. That's that. I'm gonna pick I don't know, let's pick 3 off. I'm gonna pick a pulse here. I'm going to press a key for the secret feature, which is one of the sequences. Not quite a secret feature, but you'll get the hint in a second and get the idea in a second. Okay. One of the most fun things in the world is to change settings of filters while there's a sequence playing. And some of you might notice this progression. Others know. You can watch the notes come by here, and maybe that'll be a clue, maybe not. What that is, it's a song, it's a sequence made popular by Pink Floyd on their Dark Side of the Moon album on a track called On the Run. And while this is playing now, I can do a few things such as, I don't know, enable the filter, which as I have before. So I'll turn that on. I'll pick this guy. To use it, I'll set the cutoff here, and I'll start the LFO. Now you could set this to a really low frequency by pressing the less down sign. Even slower still. This will go to FF, I believe. There you go. You can do weird things like turn on sync. Oh, also hi-hats. I'll need to raise the volume on this voice, which is voice 3, which is currently, it's actually up at F. I'm going to raise the resonance again. Okay. Now I'm going to bass drum on. And you can also play, I think, if you want to. But anyway, I think you get the idea here. Oh, there's also, I should mention that drum beat, 4 on the floor drum, bass drum, the hi-hat on every step is courtesy of the Dream Chip. You can see the light flashing there. Maybe you can on the camera. The extra percussion you hear is nothing more than the filter reacting on a synchronous, synchronizing the two oscillators. If I turn sync off here, is this? Let me see. Yeah. Let me try it on this voice. If I turn sync off here. See the difference? I'm not sure picking a waveform matters. Let me just try. No, it doesn't. What if I pick a triangle waveform and then turned on ring modulation on both oscillators? Maybe I need a triangle here. No pulse. Yeah, a little bit different, isn't it? What if I do, let's see, if I do, can I do the third here and the fifth? So anyway, there's a lot to do, right? So much to do. I'm going to change this back to a pulse. I'm going to change the width of it. I'm going to change the voice on 1 to a sawtooth, pulse off, sawtooth on. Sorry, triangle, nice and mellow. Want to have a longer attack. So I'm going to press this to select voice 1. I may not have mentioned it, but it slows down considerably when I flood the serial port with data. I'm going to address that. What if I turn on ring modulation here? Yes. Last thing to show you is other percussion built into here, like snare drum. So that's nothing to do with the noise waveform here. I pressed on accident. There we go. Also, cowbell. Also, change the filter inadvertently. I think it's G. Yeah, it's G. Right? Another one is closed hi-hat. Yeah. Now, closed hi-hat's interesting. Let me stop this 1 second just to demonstrate. Closed hi-hat's interesting because in General MIDI, the Dream developers did a great thing with it. They bound the open hi-hat and the closed hi-hat together such that if I gate the open hi-hat with the closed hi-hat, it chokes it. Just like a real hi-hat, right? Pretty cool. Anyway, you get the idea, or get some ideas from this. And also, you hear the reverb on that, right? If I do, hear the long reverb tail. That's courtesy of the Dream chip, right? If you had to model reverb and actually do something to affect some kind of mathematical calculation of an echo, it would take the full computer. Of course, you can do that in a DAW, in a, you know, whatever, 32 core or something or other modern computer. But in this one CPU system, having this utility is pretty impressive. So that's all I have. We'll see you next time.